starting from, because we are running out of quality rock in the future. Bega Road field site in Kingston. That Bega Road is one of our like a council sites, as you can see here. This is the Bega Road area. This is the spoiled site. Kingston is a suburb. In 1985, it looks like that. In 1985, we were burying concrete in this property because those days we did not have any other alternative method. We have been burying concrete as a spoil disposal. So later down the line, we were thinking of Australia's plan to reach net zero carbon footprint by 2015. Now, in this event, I would like to describe a little bit further what is this carbon footprint and how it affects us. What is carbon footprint? Carbon footprint is like an emission of like a carbon dioxide or greenhouse gases and in tons by a human or organization act. What is this greenhouse gases? In way back in Kyoto, I think it's 1975, they have identified these 6 gases as greenhouse gases. So I am going to a little bit describe this because sometimes there's like a huge impact on this carbon footprint to our recycled material. These gases I am not going to describe: carbon dioxide, methane, nitric oxide, and other 3 gases. They describe as greenhouse gases. When we emit these gases to the atmosphere, what happens next? Now, the sun is discharging like a heat, and it comes as a radiation, and the earth is reflecting this infrared back to the atmosphere. We have these gases in the atmosphere, carbon dioxide or methane, and it will reflect back, re-emits the heat back to the earth about 50%. And that is where the global warming is coming from. This is called greenhouse effect. And that is why when you have more of these gases, heavy gases, not like hydrogen or oxygen, the emission of this radiation comes back to the earth more and more. As a result of that, the global warming is happening. Now in Australia, plan has like a go to carbon net zero by 2050. What does that mean? Either to reduce this carbon, the greenhouse gases to zero, or to replace these gases or by some other different like methods. Share of work carbon footprint. Now this is actually the snapshot of 2020. As you can see, the China is contributing about 28% of carbon like a footprint. And now we go back to this. This is like one slide I got it from internet. But this means actually the China is the most biggest culprit. But if you go to the next slide, in the outer curve, you can see 27 point is created by China, but their population in the worldwide is about 20%. But in the orange color one here, you can see this 15.6 carbon footprint is emitted by USA, but their population is 4.5. So when you are talking about this the carbon footprint, we have to go by the population, like the ratio of population. I'm not going to describe more. This is the outcome of that. The green cleaner roads for Logan. Based on this background, we thought of having green cleaner roads for our Logan Council. And later down the line, in 2019, Bega Road, same field site, we started like a crushed concrete in this area. Earlier we were burying, now we have been crushing concrete and give that free of charge to the contractor. So we wanted to get rid of the material, and then we gave material back to the contractor free of charge. So he comes there and then he crushed the material and then he take the material away. That was 2019. And later down the line, I was thinking about this recycled crushed concrete, and the benefits are like it is cost effective. Significant quantities of valuable non-renewable natural rock material can be saved. That means, as I described you earlier, we are running out of quality rock, so we can replace that rock. Extend the lifespan of landfill. That means actually if we have X amount of years, we can like expand the lifespan of landfill. Decrease the carbon footprint. As I already explained to you, the carbon footprint has a very significant impact on the global warming. The use aggregate and sand all in aggregate, which I'm going to describe later down the line, that can be used as a manufacturing of concrete. Considerable amount of transport costs also can be saved if you are using recycled crushed concrete. Soil waste management in Logan Council. We have something called Browns Plains Fill site. They emit 59 tons of carbon dioxide equivalent carbon footprint. That this is a complex calculation, but this is the outcome. In our division where I am working, we like a discharge about 10,000 tons of concrete spoil. That is tons. The other one is 59,000 tons of carbon dioxide equivalent. They can calculate and convert that into the carbon dioxide equivalent. So Logan City Council vision, actually, we would like to have this 2022, the carbon zero, like as a zero carbon dioxide, like a carbon footprint as zero. Our target is, that's our target. I have been given the task to propose a specification. Literature study has been undertaken. I studied Queensland like a specification, like a transport main roads. These are the specification. Then I studied the Victorian Vic Road specification. Then went to the Western Australian. Finally, I studied the New South Wales IPW specification 2010 for like a recycled crushed concrete material. Then finally, I studied huge amount of other like a literature around the world, from India, New Zealand, and then so many other different countries. Finally, I came out with like a suggestion to use the IPW New South Wales specification to suit our standards in Logan. Now, this is the IPW specification 2010. I could call it a greener specification. And in one of these pages, we have two different categories of like axle loads. This axle load is more than 1 million standard axles. The second one is R2 is less than 1 million standard axles. You can see the grading bands here, and the UCS value, unconfined compression test, has given as 1.5 megapascal. This is too high. If you have 1.5 megapascal like unconfined compression test value, that means this material is behaving as semi-rigid category. If this is less than 1, this will behave as granular material. The reason that we are treating this as granular material, I suggest to modify this to 1 with amendments. And if you have this UCS value less than 1, this is behaving as granular material, as the material or the pavement will have less cracks, or it will not have any, it will not prone to any cracks. And Bega Road, that I am going to show a little video. Now, this is the area where we are crushing material. We bring concrete spoil from the council, and it will dump from this clip here. And initially, we collect this material here, and we deploy like a mobile crushing plant. Initially, we hired like a jaw crusher, which crushed this concrete into bigger pieces. Unfortunately, this is like a jaw crusher, as you can see here. The backhoe is like a excavator is loading the material to the crusher, and this is the crushed material, once crushed material. Then this crushed material is going through a secondary crusher, which you call a cone crusher, and it is loaded through a screener here. And as you can see, the screener is screening the material, and this oversized material going through the crushing plant again. And now, as you can see here, there's a huge amount of dust emits under this like operation. We engage a water cart, and the water line is connected to the crushing heads to reduce the dust. Actually, you can see the water cart here. This is the water cart, and the water line is connected to the crushing heads. And after that, we get the graded aggregate which we require. This is the graded aggregate recycled process crushed concrete aggregate. And silica dust issue came as a very high safety issue. As a result of that, we wanted to reduce the silica dust. We deploy like a water cart throughout the flushing period. Now you can see the water cart is watering, and actually we control the silica dust or the dust emits by this operation. This is the production line where we crush material in Bega Road. And we test material like deploying like an independent laboratory, not a laboratory, and they come to the site and they take samples and go through the sites. Initially, as you can see here, these are the like a sieve openings from the IPW specification. Maximum, the red color line is the like a grading band. Initially, the test has been failed, and then actually the grading was out of control. And then we add like a 9 to 1, 92% fine material to get the grading band into the envelope. While we get the grading band into the envelope, the CBR value went off from the specification. The R2 specification RPWA, they define CBR value, Californian bearing ratio, 4 days soak as 60. And then we add 1% and 1.5% cement to get the CBR value up. However, this has been done when we have a one crusher, only the jaw crusher. Then we did numerous number of tests, and then we add the secondary crusher. Now, as you can see, all the gradients came into fall in line with the envelopes, and the CBR value was satisfactory. And now you can see the coefficient of curvature. This is like a soil mechanics touch base. I don't want to describe there. As you can see, this is the curvature line. D10, D30, and D60 is like a percentage passing and then plotted down the line. And then you get the D10 and D30, D60. And then you have a formula. The CU is D60 divided by D10. Uniformity coefficient. Coefficient of curvature is CZ. D30 squared divided by D10 multiplied by D60. If this CU is more than 4 and then CC is less than 3, we call a well-graded aggregate. In our case, both of these values were satisfactory. Now, summary of test results. Now, as you can say, we tested CBR values. The minimum is 60 in the specification. We get like an average value of 82.5%. Test 5 tests. And the liquid limit plasticity index and plasticity limits were tested it within the tolerance. And we checked the WPI, weighted plasticity index was 180 in the specification. Our value was 100 wide. What does that mean actually? Under the influence of water, the material try to behave like it swells, and it create inverted cone cracks on the pavement. So if you have this value under control, there won't be any cracks. The next value is weight and dry strength variation percentage. What does that mean actually? When you roll this material under the influence of roller, the material create fines. So if the fines are more, then we have again trouble. So if the specification says 40 maximum value, we have like a 28.67 value. Some people think just because this is crushed concrete, it will create more fines. If this is the norm for that crushed concrete or any other granular based material, if this value is within the limits, and we don't have to worry about these fines. And the UCS value, as you can see, it is well below the average value, which is less than 1 actually. So this material most definitely behave as a granular material in the pavement. Now you can see the field density test, and the field moisture content was lower than the optimum moisture content. And what does that mean actually? People did not add enough adequate water at the site. So we have to fix this issue. Maximum dry density, it's about 2.2 tons per cubic meter, which is very similar to 2.1 gravel. Field density was 99% or 98% modified compaction. So this indicates that this material is very suitable to use in our road pavements. Cost comparison for traditional 2.1 gravel base road versus crushed concrete road base. Now traditionally we use 2.1 gravel base cost. And in this comparison, this is comparing only the direct cost. That is, intangible values are not considered, like carbon footprint or land saving values. Now we have two different payments options. One is subgrade. On the subgrade, we have 150 millimeter thickness 2.3 gravel. And on top of that, we have 150 millimeter thick 2.1 gravel. The cost was 94,000 plus. And the second, we compare that with 300 millimeter thick recycled crushed concrete. The length of this comparison is about 500 meters. Width is about 7.2, like a nominal, like a 2-lane road. The cost comparison is this cost is came to about 47,534, and the ratio of cost comparison is approximately 2. That means it is very much cost effective to use this recycled crushed concrete compared to the 2.1 gravel. 2.1 gravel is the traditional gravel we use from the TMR specification. Now, construction and demolition waste statistics, and 20 million tons of waste is producing in Australia, and it is 22 and 2000 year it will be double, and it will be triple in 2022. So in approximately we have in our division 10,000 tons of concrete producing. Then national specification, I am not going to go into details. There's a specification called national specification. They have published a research paper in 2019 April. These are the types of material they use in Australia. The wrap, like a pavement material from the asphalt part, plastic, and then recycled crushed concrete, so forth. Case study news, Western Australia has done a lot of work, and this I will just glance through this one. 2008, they have done the pavement construction in Western Australia. This is their work, and they have add lime to their pavements, and they add using a grader, and then it's it's like a in situ stabilized base, and they add this lime and they spread the gravel and they compact the gravel. So there are research papers. If you need more information, please feel free to call me or contact me. As the time is limited, I am not going to go through all of that. So this is again the comparison of virgin aggregate, that is traditional aggregate, versus a recycled crushed concrete. The carbon emission is less, as you can see from here. Case study New Zealand. Again, New Zealand has done a 2005 road, and their whole road was done using recycled material. The sub base is done recycled concrete, and that is all passing. That means AP60, that's 60 millimeter downwards, and 100 millimeter thick all pass in 40. On top of that, they had a wearing course, 80 millimeter wrap. That means 14 millimeter thick. 48% of wrap plus 2% bind. Then design lives and everything else given here. This is just an example. Case studies of Gold Road, Christchurch, that is this is before and that is after. Road Construction and Maintenance Division, Logan City Council, construction team, trial projects. And in 2019, we did this project, and this is our first field trial project in Eagleby, Logan. In this, you can see the cracks here, and then after that, we use this recycled crushed concrete on this road. And these are the cracks, alligator cracks, and then on the roads, and then the vertical longitudinal cracks also we can see here. This is the site. Then we had a drainage blanket, and this is geotextile because there's a drainage problem. So we did the drainage blanket and wrap around with that. And finally, we use the recycled crushed concrete on top of that actually. This is the final outlook of this pavement after about 4 years. So it's behaving perfectly okay to date. And this is Chambers Flat. We recently this road. I am going by field trials because then you can see what we are doing actually. This is 2021, very recent study. This is our second road project. And this is initial road, the existing road. And there's a graders actually spread the subgrade. And this is the recycled crushed concrete you can see here. And we export that one to the site. And then actually after that, we had like a composite geogrid. On top of that, we laid this material. And this is the truck and dog with the material here. And they are spreading the material. After that, you can see these people are picking up something. What is that? That is the reinforcement parts coming from the production. They pick up this material. That's like a something that we have to fix later down the line. These are the reinforcement parts coming from the production. Normally, there are like a magnets in the crushing plant, but they can pick up only 80% of the material coming from the crushing, the reinforcement coming from the concrete. Now, after that, they spread the material. After that, they roll it using like a pneumatic tire rollers and the heavy trail rollers. And then you can see that we spread the material here. And this is just before the wearing surface. And the road looks fine. And this is after wearing surface, final layer. And then you can see a close look up of the final layer here. And all in aggregate. What does that mean? Normally, concrete has fine aggregate and coarse aggregate. Less than 5 millimeter falls under fine aggregate. More than 5 millimeter is like described as coarse aggregate, as you all know. And all in aggregate, we have this both component in one go, one mix. That is called all in aggregate. So what we did, we were trying to get 25 MPa megapascal concrete, that is grade 25 concrete, using this material to use for our like a footpaths, that is non-structural concrete. Now, as you can see here, this is the percentage we add with this material by weight: 75%, 50%, 40%, and 25%. In 7 days, like a compressive strength was 13 and so forth. Actually, you can see the values here. In this graph, you can see the 7 days graph is like in the blue color graph. Based on this 7 days graph, we anticipate, that means actually we anticipate 70% of this strength achieved within 7 days. So final outcome is in the red line, that is like a 28-day strength. That is the projected or anticipated strength using this percentage of cement. Now, if you wanted to get 25% MPa value, so you can go to the graph and project this side. So you can see if you add between 30 to 35% cement, then we will get 25 MPa concrete. So I am testing that. This is a laboratory test yet, and we are looking forward to get this on action. And then once the laboratory test results get through, we will try this recycled crushed concrete pavements or the material or concrete on our footpaths. Challenges. Challenges fall under two categories: technical challenges, non-technical challenges. Technical challenges. Silica dust issue. If you inhale silica dust, we get like a cancer, lung cancer. And sprinkler system was not adequately working, so we have to improve the pressure lines there. Could not remove 100% metal parts or reinforcement. As I told you earlier, that was an issue, but we can like remove about 90% of them. The appropriate plant and machinery must ensure that the production process is economically viable while achieving the required quality standard. That was an actually technical challenge. We have to use the proper machinery. And dust mitigation results. Queensland standard is 0.05 milligrams per cubic centimeter. And that is Australian standard. We tested the people who are working there with dust monitoring devices fixed into their like a body, and it is well below their standards. That was a really challenge for me because the silica dust issue came recently. And actually, as you can see here, we are like proposing to install sprinklers in this in the yellow colored dotted line area to reduce the dust. And technical challenges is another thing. Actually, as you can see, this reinforcement particles are coming into the site. That is, we have to do that. Non-technical challenges. Recruitment issues, we are council, we have like a guidelines, we are doing this research work or like innovation projects, but this our hands are tied with the guidelines. So difficult to attract contractors as many consider quantity was too small, because there are large big contractors, they don't like to come and work for us because we have only limited amount of concrete there. Reluctant to take on the new outside the box solution. This is a very, very important thing. As engineers, we need to go outside the box and then put our foot forward and then go and do some research work. Reluctant to change the current practice. We have been going through the same traditional old way. Basically, when you say this, the change is pain. That's what it is. Lack of confidence to carry out innovative trials. So these are like a man-made issues, actually, unfortunately. Take home summary, categorize the council roads based on the estimated standard access and allocate the funds to maximize the benefit to the taxpayers of the council. What does that mean actually? Now if you have like a small animal like a uh, donkey, we take a stick to manage him. But if you have an elephant, we don't use like a stick. We take a like a something like that to manage him. So this is the concept. Now, normally, when you have 8.2 tons of single axles damage to the road considered as one standard axle. And this slide show if there is a car going on the road, the damage to the road is 0.007. Or as you can see, when the vehicles are bigger, you get bigger, heavier damage to the road as ESA. And in Logan, we don't have this like A trains or B trains like in your right side actually. But now this is the map of Logan. Now can you see, please see this one. In the green color, we have less than 1 million standard axle roads. And the yellow color is more than 1 million standard axles. 80% of our roads are less than 1 million standard axles. We spend money just for nothing for these roads and using like a gold plated like a specification. Unfortunately, we have to like a differentiate the specification based on our like a standard axles. That is what I was telling about that earlier. And take home summary again, pay adequate attention to improve the carbon footprint by adapting modern technology. That is what we are doing. We have to adapt modern technology and reduce our carbon footprint. That is for our future generation. And reduce the purchasing of carbon credit. Now, sometimes what happens when you can't bring the carbon footprint to zero, then we purchase carbon credit from some other countries like India. Now, that is very, very weird thing to do because we purchase and when we tell our carbon footprint is zero, we have to go that in global carbon footprint as like a concept. So we need to take action for do that. And encourage council engineers and policymakers to take calculated risk, look out of the box, technologies to improve road construction practices that need a new facelift. That means we need to take risk as an engineers. We have to take risk and then we have to go forward. Understand the needs for innovative strategies and facilitate them in the council procurement framework. That as I have explained that we need to accompany our procurement strategies to facilitate the innovative projects. Run more free trials and improve and increase recycled crushed concrete usage in the council roads on a broader capacity. If you don't do any research, if you don't do any trials, we will never learn. We need to learn. We need to fail. That I am fortunate to tell this because my manager is encouraging us to do any road projects, and as a trial we can fail. Then actually we have to allocate some budget to the innovative projects. Change the old way to the new way. If you don't do anything, nothing will change. Acknowledgement to the Mick Savage. He was the person who wrote that specification in 2010. And there are so many people down the line. And I'm not going to tell everybody here. And there are so many other people. Dr. Chaminda Galage is from one of our Sri Lankans from the QLD. They came to research work with us. And finally, IPWA, and special thanks to Asoka, and then Dr. Siad. If I don't mention any of your names, please forgive me because I don't know much of these people. Derek, he was going through with me all the time. Jayanta and all the people. Chanaka was encouraging me. It was great pleasure to be with you and share my knowledge and experience with you. Final thanks. I was working in Road Development Authority Research and Development Division way back. So I had to thank them because this background was coming from them as well. Finally, IEL engineers, are we ready to take up this challenge as Australia plans to reach net carbon zero target by 2050 and save our future generation to innovative products and use innovative techniques? Of course, we are happy to go to take that challenge. That is our responsibility. Thank you for listening. If you have any questions, I would like to answer for the best of my ability. Thank you.
Thank you, Ruchitha. Indeed, we are ready to take that challenge. It's an exciting time to be in Queensland, especially Olympics coming in 2032 in 10 years. So it's really an exciting time for particularly engineers with some major projects in pipeline. Thanks a lot. It was a very interesting presentation. Sorry, I just admit. Chanaka, could you take care of the people coming into lobby?
And one more thing, if you need more information, please feel free to call me because I can share my experience, because this is a limited time a presentation. So I have written a presentation like a thesis, so you can read that or talk to us, that sort of stuff actually.
Yeah, thank you, Ruchitha. That was really interesting presentation. The floor is open for questions, but please keep it brief and please make sure that you unmute your microphone before asking the question. I want to start by asking one question. Particularly, I was a bit intrigued by your comment that the quantity is very small in Logan City Council. Is there any initiative for some form of collaboration between, for example, Brisbane City Council, Ipswich and Gopal City Council, so that there will be some worthwhile quantity for you to explore the option further, because saving is pretty significant?
Thank you, Dr. Siad. Very good question. Because the issue is this actually, we started this actually, some people use this recycled crushed concrete as drainage material. Very easy to produce that. Now, this is the graded aggregate. So we have to put more effect on this one. Now, answering your question, Logan is in southeast that side. And if you are bringing material from here and there, it will not be cost effective. But only thing, if you develop this technique, then we can tell them what we are doing. We can share our knowledge, and they can have their own plants, because this mobile plants can go anywhere. Now I am using mobile crushing plants actually. The other thing actually, we are dealing only with the council spoil concrete. That is our road projects. There's another spoil site in Browns Plains where their general public dump their concrete. So if I am successful, I can tap that. But only thing, I have to do more field road trials to tap that. There's a huge amount of concrete sitting there. They crush, but they don't use that as road-based material, but they use as like a drainage material. Drainage is like a single site or something like that. Actually, easily we can do that. But coming back to your question, we can share information with Brisbane and Moreton Bay, where I am living here, and then actually they can actually cross a reference actually. In fact, my manager told me to put my contact details in the IPW space, like a presentation. I am going to do that very soon, next week, and to talk to us. And then his word was we have to be big brother for them actually, because we have resources there.
Correct.
So I think I explained your, is that right?
Yes, yes. Thank you very much. There are a couple of questions coming through. Yasin, would you go ahead and would you like to go ahead and ask your question?
Okay, thank you very much for the presentation. I am Yasin Isa from Roads Authorities in Bahrain. I appreciate too much for this presentation. So I have just a couple of questions that are related to application of the construction and demolition or recycled concrete, as you say. Uh, Considering that uh, such kind of material is known to have affinity to water, just was asking how this material would be dealt with in case or in locations where shallow groundwater table are there.
Uh, if I understood you correctly, sound like a groundwater. If they have, then you have to think about drainage first, because the road, there are three enemies for roads: water, water, and water. So we have to take the water out first of all. Actually, you need to put like a subsurface drains or like a deep drains in the vertical, like a table drains in the sideways, and that is another thing. But if you have a little bit of water, I don't think there will be a problem, because as I told you earlier, the WPI, the weighted plasticity index, is a component as the culprit. If under the influence of water, the material swells. We had like those cracks actually, and the material pushed the pavement upwards and created an inverted cone crack. That means this side, not like that like that, and inverted cracks. So answering your question, I think it's better to get the water out of the pavement. And if you have a little minor amount of water, because we have tested the liquid limits and the plasticity limits, and the CBR value is like a 60, 4 days. So under the water, because we test the CBR with the water under like in a water tank, so there won't be much problem. But if you have huge amount of water, that will be a problem for any road pavement. The other alternative method is add like actually geofabric or composite geogrid. Composite geogrid means geofabric plus the geogrid together. That's what we are using at the council in this moment. So if you need more information, please feel free to call me, because I am happy to discuss with that later down the line. Is
Okay,
that
that's fine. So do you have any minimum level that you are recommending for the recycled concrete to be used in case of the effect of groundwater table that comes up and down?
way back when I was studying in research, actually, when I was working, actually, my deputy director, Mr. Mallavarji, was saying the water table should be 2 feet below the subgrade. That was like a thumb rule. That was way back. And but for any material, that's a rule, I think. But we don't have much information about the recycled crushed concrete. It is not different from any other material than like a 2.1 normal gravel. So we need to keep the subgrade water table below about 2 feet, means actually about 300 millimeter below the surface level, actually below the subgrade level. It's better. Otherwise, what happened? Infiltration, actually the capillary action will take place, and eventually the road started deteriorating little by little, not at one time and straight away. So better to keep the water table down, cut the drains in the sideways, or put like a subsurface drains, and then take the water away from the pavement best as you can. And I know the Bahrain, actually they have like a very silty material, and the levels are very low, closer to the sea levels, and very difficult to take the water away. So at that time, then you can put like what I can't remember what's the term actually. The big like cylinders, they can like dig that and then put that into like a sideways and take the water away. That's the best way to go. So asking about the recycled crushed concrete, we don't have much knowledge about how the water level should be down. But for any granular material, it should be about 300 below.
Thank you,
Okay.
Ruchitha. Thank you, Yasin, for the question.
Just one more question, please, if you allow. Just recently, we have started the application of this material in Bahrain, and still we have just conducted some of the test trials. So we have noticed that the materials are not properly bonding together. unless otherwise natural materials or another binder being added. That is one of the observations. So
Yeah.
what would be your recommendation, please?
Yeah, that's a good question, because if the material is not bonding, that means actually there won't be enough clay particles. That means not enough fines actually. So if you have a graded aggregate like that the curves, that should resolve the issue. But if you think that is not adequate, you need to add more fines, like what I did actually, add like a 9 to 1 or 8 to 2 percentage of fine, like a corridor dust or something like that, and actually increase the like a fine material so that it will bond. Because what happens when you crush this one, you get bigger particles, you don't have the fines. So you need to get like a whole component series of sizes of aggregate. If the fines are less, this will come back. This is the problem, comes from there. So fine material, no, clay is not brown color, it's a fine material anyway. So when you have enough fine, it will bond the material with the bigger particles will bond with the smaller particles. So you need to add a little bit of fine particles and do some like a variation and test the grading bands, and then go forward from there. You need to do a little bit of trial, like a laboratory trials probably.
Thank you, Yasin.
Thank you.
Some of the questions on the chat lines is mainly about getting a copy of your presentation and getting your contact details. Please feel free to email to info@ieslqld.org, and then we will share the information whatever is available to us. So that's info@ieslqld.org. We'll put that detail on the chat as well. We have sorry.
I am going to present this one in the IPWA, and there's a booklet, but you can take the booklet after after end of this week actually. That gives a huge amount of information, about 40 pages.
That we have another question. Apologies if I didn't pronounce your name properly. I think it's Niren Mehta. Yeah, please introduce yourself, and then please go ahead with your question.
Yeah, this is Niren from Ministry of Works in Bahrain. I have very brief two questions. One is, the one which you shown about definitely there is a major cost difference between using the brand new concrete material and also this recycled material. However, when you show the slide for the carbon footprint itself, there is not much of a major difference. Is that correct? What I interpret?
Firstly, actually, it's not concrete. The one option one is a normal gravel. In Queensland, in Australia, we call 2.1 gravel. That is like a normal aggregate. Like in Bahrain, I think they actually call it's an aggregate base course, actually ABC or something like
Yes,
that.
yes.
40 millimeter downwards actually.
Yes, correct.
But that is not concrete. It's like in Australia, in Queensland, we call gravel. In Sri Lanka, when you call gravel, it's like a different liquid material. So in Queensland, it's called gravel, normal aggregate base course comparing to the crushed concrete. But the ratio is around 2 supply and lay based on the intangible values. That means the carbon footprint effect and the long term land saving values were not considered. And the other thing, actually, if I can produce this effectively, I can bring that cost ratio higher level to higher level. But I have very few contractors. I have been working in this crushing business in the council for 10 years. Only one contractor came, put up their hand, because we have limited cost, quantities. So the other thing, actually, the people from my division, they are whinging, they are telling, I am charging more, because this is like left pocket, right pocket thing. If I produce, I have to sell them. So they have to take them. And I said, okay, you buy more, I will give you less. It's like a business actually.
Yes.
So when you do more, I can reduce the price, because then I can bulk product.
No. My question was not regarding the price. Price I can understand, because once you produce more, obviously that will becomes a wholesale market, and then obviously the price will go down. And even though now what you've shown is 90,000 to 45,000 something, which is roughly about 50% cost saving. The whole idea is obviously one is to get rid of the waste concrete material there in the place where you're talking about, and also the main idea is to have the sustainable making a concrete which reduce the carbon footprint. My question was that in your presentation, it shows two of those is almost the similar. If you take out the brand new outside material, not even the going to the granule and the different terminologies, but it's exactly almost the same. So is that actually reducing the carbon footprint itself, or is it really maybe increasing the carbon footprint in effectively?
No, it will decrease the carbon footprint because actually we are getting rid of this concrete now. That means actually it will impact the carbon footprint and reduce the carbon footprint because we don't bury this actually. At the end of the day, we don't produce carbon dioxide or anything like that. So as a result of that, carbon footprint will come down and the land saving values because we have limited space to bury this material. That's a huge amount of dollars. So we can extend that actually now if you have a 10 years lifespan, that will become 20 years. So there's a money value come from the intangible values that has to be calculated. It's a complex calculation. So in the beginning, I said it's a direct cost calculation only.
Correct.
So that's the answer. Actually, that's a direct cost only. Indirect cost like carbon footprint and land saving values and so many other calculations are there, which is difficult to define. But even right now I have formulas, but I am not really don't know how to calculate this carbon footprint calculation.
Thank you,
Right. Just very briefly, then these are like sort of a scrap material basically. So does based per your experience, does it actually affect the quality of the material, or do you need to do like a frequency of testing much more than the normal ones to make sure that the final product, which is going to be at least in a certain band, to sell it out, or
yeah, again, that's a good question because at the TMR specification, our main roads, they have like a X amount of load. This has to be tested. This test has to be tested this much of testing. And in the main roads, again, they have like a different specification for recycled crushed concrete. We need to define that. The correct answer, we don't know because we need to test more and more. And when I am sending this material to the site, I test many times because as I told you, they don't add water. So I add water from my a production line and then get a person to test the laboratory test with oven a moisture content. And these tests, you are asking the sequence of testing for the recycle. No, we don't know. But actually normal gravel we have. So we treat this as normal gravel as today. But in the future, if they are going to take more, if there are some failures coming, then we can put a figure, like X amount of cubic meters CBR test to be done for that 4 or 5 or something like that. And the MTRS specification is very clearly mentioned about those gravel type, like a testing regime. So we can adapt that at the moment. But in the future, we are ready to change it.
Thank you, Ruchitha.
Excellent. Thank you. Thank you very much. Thank you.
So thanks, Naren. Because of the time constraint, I'm going to just allow one last question from Kokila Arundara. Please ask the question. If you can keep the question and the answer brief, that would be appreciated. We only have a couple of minutes to wrap it up. So thank you, Kokila. Please go ahead. Kokila, are you there? You're still muted.
Hi, good evening from Sri Lanka. I'm calling from Sri Lanka. Very happy to hear and see the progress and all the success stories. So I'm also one researcher on this area. So I have read several articles from even Dr. Shihan and even willing to read this said material. I'm working and trying to research on using of recycled concrete aggregate as a material for rural road concrete roads in Sri Lanka. So at the moment, I'm working on the basic fundamental activities with the researchers, but go with as you mentioned, the real field works. So I would like to have some guideline. So if we are working to have some trial roads with the concrete roads. So in Sri Lankan context, what kind of guideline or what kind of advice engineers you can give us?
Thank you very much. When you say concrete road, we did the first concrete the first concrete road in Sri Lanka has been done in actually in the Jaffna somewhere in the Chunnai market. Second one was done in actually Palavi Kalladi Road. Mr. Derek Fernando is here. He was the provincial director at that time. And if you can recall, actually, I was from the research and we did. I think best thing not to go to concrete road. When you say concrete, it's rigid road. It's giving too much trouble actually. This is not a concrete road. This is like a granular material. Actually, that is called life after the death. Normal concrete crush and then use this as recycled crushed concrete. If you are going for concrete road, that gives a hell of a lot of trouble because you have to put a reinforcement, then the track inducers and all sorts of like a pavement thicknesses coming, and it's very difficult to manage and then very difficult to maintain. So talk to me if outside this line, and then your director, she can talk to me, and then I will help you because there are huge amount of concrete spoil has been there. We need to use that material. And in the 2000, like a 4, the tsunami, I saw huge amount of concrete waste. At that time, we did not know about this. However, concrete road is one thing, rigid pavement, very difficult to manage. Crushed concrete is a granular material. It's a different, like a animal here. So we need to use it. That actually, that is best way to go. Rigid pavements is difficult because you need to put crack inducers, thicknesses, and all these things are coming. First 2 roads has been done according to my understanding way back. I don't know after that what happened. And Mr. Derek Penandu, I am really happy that he helped us in that contest in the Northwestern Province, Kurnagal Provincial Director. He was one of my bosses earlier.
Thank you, Ruchitha. With that, there is a quick note from Emil Fernando for you. I think you would probably love to hear that. Thank you for that interesting presentation. Emil, the one who took over your Bragala landslide project. You ran away, Ruchitha, and he took over in R&D Sri Lanka,
That's
and
another.
now working in Bahrain. All the best, my friend. Thank you, Emil. With that note, I will have to invite Buddhi to deliver the word of thanks and virtual memento. Before that, the email I've put it on the chat line. Please have a look at it and then email to us. We will arrange presentations and if Ruchitha is willing to share his contact details, we will be giving that as well. Buddhi. Sorry.
Yes, right.
Just a second.
Hello.
Okay, all right. Buddhi,
Right, okay.
Sorry, over to you, Buddhi.
Right, thank you, Ziad. I would like to take this opportunity to thank Ruchitha so much. It was a very informative session, and it was very insightful, and especially given this time and day of age when the carbon footprint is one of the biggest culprits that we have. Now, I would like to share my screen. I hope everyone can see. We have prepared a memento to be given out in appreciation to Ruchitha for his amazing talk. Unfortunately, because of the aftermath of COVID, we still are hosting these sessions virtually, but we will make the necessary arrangements to have this delivered to Ruchitha in the coming days. I would also like to thank 4RIBI for promoting this session on their radio channel for all this time. And also, I would like to thank the ICT team, especially Tushara, for doing all the technical magic behind the scenes to make this session a reality. And also, we would like to thank the technical subcommittee and all its members for helping us to put this session together. Not to mention, we have to thank the management committee, the subcommittee members, and also our esteemed members for supporting us throughout, and all the other members from other chapters who are present with us today. And last but not least, I would like to thank the audience. You have been a great audience tonight, and thank you for all the questions coming in, and I hope you all enjoyed the talk today. Thank you very much. And I would like to hand over to Dr. Ziad again.
Once again, I could not mention about 4EB because that was one of the people I should thank. Sorry about that.
Thanks, Ruchitha. Thanks, Buddhi. Please feel free to search for us on Facebook. That's IESL Queensland chapter. We have some very interesting presentation to come through in the future. With that, I close the session. I thank you for joining and asking all the interesting questions. I would love to continue this the whole night, but everyone has to go back. Enjoy the rest of the weekend and have a good week ahead. Thank you very much, everyone.
Thank you very much. Good night.
Bye.
Thanks. Thank you very much.
Thank you very much, Mendes.
Thank you. Bye bye.